Hello everyone, welcome back to the brand new lectures in physics. So in the previous class we have dealt with some examples related to the derivation of relations between the physical quantities. So in this class I will just want to explain one more example and explain the disadvantages of dimensional analysis as well. Okay, so let us quickly get on to the example first of all. So here the formula for velocity, okay, was given in terms of universal gravitational constant G R A and mass per B and the radius whole per C. So I just want to find the values of A, B, C in this case. So we all know the dimensional formula for velocity will become L into T inverse, okay, which is equal to the dimensional formula for G. So what is the dimensional formula for G? Let us quickly write here. So the dimensional formula for G will become Newton meter square per kg square is the formula. So which is equal to kg into meter per second square into meter square by kg square. So here kg will get cancelled. Here will get kg inverse meter cube and second power minus 2. So it itself means that its value is m power minus 1 L cube and t power minus 2. Okay, so this was the dimensional formula for G. So let's quickly rub this and write the dimensional formula here. So that is m power minus 1 L cube and s power t power minus 2 into this mass is nothing but m. It is simply m. Okay, here power A and here power B. And the radius is nothing but it is length whole power C. So this was the formula. And now L into T inverse will become, this is m power, so this minus 1 whole power A, so that means it is minus A, okay, plus B, minus A plus B, and there is no m term in the third one. And next here L power 3 into A, 3A plus here this is C and t power minus 2A plus nothing is there, sorry. So this is just minus 2A. Okay, so from here we all know we can easily write this equation like m naught L t power minus 1. So from here on equating the powers of two equations, here we get minus A plus B is equal to 0. And here L power 1, L power 3A plus C. That means 3A plus C is equal to 1. And here this one minus 2A is equal to minus 1. So from this we can easily get A is equal to 1 by 2. A is equal to 1 by 2. So writing the value of A in this equation, you will get C is equal to 1 minus 3A, that is equal to 1 minus 3 into 1 by 2, that is equal to 1 minus 3 by 2, which is equal to minus 1 by 2. So that means you have got the values of A as well as C. And finally, here B can be written as simply it is the value of A, so that means A and B are having the same values, so which is equal to 1 by 2. Okay, so these are all the values of A, B, C. So finally the value of A, B, C can be written as A comma B comma C. I think it is visible here. Okay, is equal to 1 by 2 comma 1 by 2 comma minus 1 by 2. So this was an example, okay, related to the dimensional analysis. And now we will deal with a very important concept called as the disadvantages of dimensional analysis. So Here there are some advantages as well as some disadvantages of dimensional analysis. So what was the first disadvantage actually? So the first one, for example, if two or more physical quantities are having same dimensional formula, two or more physical quantities are having same dimensional formula, but their definitions are different and their physical significance is different. But in dimensional analysis, it will not explain the physical quantities which are having same dimensional formula. That just means that this dimensional analysis cannot differentiate those type of physical quantities having the same dimensional formula. So this was a very, very important disadvantage. Secondly, for example, let us take an example for this. So S is equal to ut plus half at square. This was an equation, related to the equation of motion. Here, if a particular physical relation is having either a product or a division or anything, we can easily derive that particular relations using dimensional analysis. But if that physical relation consists of this type of constants like 1 by 2, 2, like pi, if these types of constant exist there, these type of relations cannot be derived using the dimensional analysis. That was the second disadvantage. And thirdly, for example, if you see this type of relation, S is equal to ut plus half at square. So this relation contains some additive terms, right? So ut plus half at square. So here this type of relation cannot be derived using dimensional analysis, and if there is any numerical error exist here, let us suppose I have just made like 3 into ut plus 4 into at square like this. Even if in this case also, using dimensional analysis, the dimensional correctness, that means the dimensional validity or dimensional consistency will be possible in these equations, even if it is physically incorrect. That is, even if this particular equation is physically incorrect, it is dimensionally valid. So that means if we just confirm that if the dimensional consistency exists for a physical relation, it doesn't mean that that particular physical relation is correct. So here I have just changed the constants here. So the change in these type of constants results in number of errors. But the dimensional consistency is valid in this equation. So this is S ut half 4at square, whatever it may be, this all the total equation follow the principle of homogeneity. So this was a major disadvantage in dimensional analysis. So thirdly, for example, if there is a physical quantity which depends upon two more physical quantities having same dimensional formula, we can't relate them using dimensional analysis. So that was the important disadvantage. And for example, if you know the values of sine theta, cos theta, or we can get log x, logarithm equations. So all these particular terms, or we can say variables or whatever it may be, so they are dimensionless according to the dimensional analysis, which is not a valid point. So these are all some of the important disadvantages. And for example, if in a particular physical relation, if a physical quantity depends upon more than 3 physical quantities, then we cannot derive the relation using dimensional analysis for that particular physical relation. Okay, so that means there are a lot of limitations in using some dimensional analysis, but there are a lot of advantages as well as disadvantages. So that itself means that it is of limited use. Okay, we need to use it according to our need and according to its consistency and reliability. Okay, so these are all some of the disadvantages of dimensional analysis, and this is the end of this vast concept called dimensional analysis. And in the next class we'll deal with some different and important concepts like significant figures, okay, and least count and rounding off, etc., which you don't know previously even up to 10th class. So these are all somewhat new concepts to you. Okay, so see you in the next class, and don't forget to like, share and subscribe our videos if you feel these videos as a useful thing. Okay, please share it to the needy people, okay, who are just enthusiastic or IIT aspirants, such that they will get basic knowledge, okay, and they will easily build up the knowledge and they will easily achieve the goals in their particular future. Thank you so much.